In this chapter, we're going to look at what is DHCP, how DHCP works, and also implementation considerations of the DHCP server service. In the next slide, we're looking at what is DHCP. DHCP allows us, as a network administrator, to automatically configure a client with the IP configuration scheme whenever the client reboots or boots the machine first thing in the morning. Instead of manually going to every machine inside of our organization and typing in the IP address, subnet mask, default gateway, Win server, DNS server addresses, we can forward this information to the computer as they boot up automatically. This alleviates any human errors in the manual configuration of the IP scheme. In this scenario, we have 3 individual client computers, and we also have a DHCP server installed. Notice that in the DHCP database, we're listing 3 IP addresses as being available for these 3 computers. Initially, whenever the DHCP client boots the machine in the morning, whenever the user logs on first thing in the morning or whenever the machine is restarted, the DHCP client will send out a DHCP Discover packet onto the network. This packet is opened by any available DHCP server on the network, and the first one to respond will be the communicating DHCP server that allocates the IP configuration to the host. So as the DHCP client sends out the Discover request, the DHCP server then responds to the client with all of its available IP addresses that it has in the DHCP scope. The client at that point selects an IP address out of the range, communicates back with the DHCP server as to which IP address it would like. The DHCP server then responds back to the client with the appropriate least value option, or how long this IP address can be retained from the client. Also, subnet mask, default gateway, the Win server, and DNS information can also be included in the IP configuration. And looking at manual versus automatic configuration, to configure TCP/IP manually, as we've discussed, we have to insert all of this information by hand. And the chance of human error is great in mistyping one of the values. Remember that 2 clients on the local network cannot have the same IP address. Also, the subnet mask must match all of those on the local domain, or the host cannot communicate with anyone. So we must pay careful attention in manually configuring all of our clients. The easier alternative is to use DHCP, the Dynamic Host Configuration Protocol. The IP addressing information is supplied automatically. No user intervention at all. This is seamless to all of our users. As the computer first boots up in the morning or whenever it's restarted, all of this information is included automatically. Many configuration problems are eliminated if we correctly configure the DHCP server service initially by creating an appropriate scope, subnet mask, default gateway, Win server IP address, and also the DNS server IP address. All of the configuration is automatic and seamless to the user. How DHCP works in the next slide, as the client initially boots up in the morning or whenever it's restarted throughout the day, we send out an IP lease request, which is a DHCP server request. The first DHCP server that responds inside of the organization is the one that will configure the client's IP scheme. The first DHCP server to respond checks its TCP/IP scope for available leases. It replies back to the initiating client as to which IP addresses it has available. The client then selects an IP from the appropriate scope, responds back to the server. The server then includes an IP lease acknowledgement allocating to the client the IP address, subnet mask, default gateway, and any other information that we have included in the IP configuration. Implementation considerations include, will all the computers inside of the organization become DHCP clients? Normally, it would be easiest to set up all of our computers inside of the organization for the automatic configuration of the IP scheme. But what happens if I only have 200 IP addresses in my DHCP scope and we hire 12 new people. 12 people in the morning, whenever they boot up, will not be able to gain access to the network because all of the IP addresses have been allocated. So if there's a certain individual in the organization, possibly the CEO, who I want to be able to always log on no matter what, I may statically assign him or her an IP address to ensure that they can always log on, which is job security for me. We also need to decide, will a DHCP server supply IP addresses to multiple subnets? It is possible to support multiple subnets through one DHCP server. Also, how many DHCP servers are required? This information is determined by how many users the individual machine can support, based upon processing power, RAM, and so on. Also, what IP address options will clients obtain from a DHCP server? Are we going to include the Win server IP address, DNS server IP address, the default gateway address, and so on? Some of the values, as we view the slide configuring a DHCP scope, include the start address, which is the first IP address in the range of IPs I wish to allocate to users. Also an ending address in subnet mask. Notice we can also include an exclusion range or a list of IP addresses that I do not wish to be allocated to users as they boot up in the morning. Reserved IP addresses, possibly for a router, for a file server, an application server, Mark Floyd, whoever it may be. It's easier, though, instead of inserting all of the excluded IP addresses from the scope, to simply leave those IP addresses from the initial scope. It would be easier, instead of including those IP addresses that I wish to exclude from the range into the initial scope, to simply not insert them in the initial configuration of my scope. For instance, if we have 20 IP addresses ranging from 131.107.3.1 through 20, and 5 of those addresses I wish to not be allocated to individual users, it would be easier to start my address at 131.107.3.1 and set my ending IP address range to 131.107.3.15, leaving off my 5 IP addresses that I wish to save for allocation. These could be statically assigned to the router, president of the company, what have you. Also notice that we have options for the lease duration. The lease duration specifies how long the individual machine is going to obtain the IP address. The default value on a Microsoft DHCP server is 72 hours. So after 72 hours has expired, the IP address is released, goes back into the DHCP server's pool, and another client can claim that IP address once it boots. We can also optionally include a name of the scope and a comment. Many of the options are listed under the heading Configuring DHCP Server Scope Options. Notice that we have, for instance, a name server. Option 006 is a DNS server, the domain name service. Also, we see a cookie server. We can implement the router information or the default gateway, Win server, and so on. In this chapter, we've discussed what is DHCP, also how DHCP works, and implementation considerations.